All right, so let's start section 8.4. This section we are looking at something called scientific notation. And scientific notation is a way to write very large or very small numbers in terms of some number that we're going to multiply times 10 raised to some exponential power. So the format would be c times 10 to the n. So c would be some number that would be between 1 and 10. So it's got to be a number greater than 1 and greater than or equal to 1 and less than 10. And the n on our 10 has to be an integer, so it has to be a whole number. It can't be a decimal fraction or anything like that. So the reason we have scientific notation, like it says, to write very large or very small numbers, and it's scientific because a lot of things that we deal with in science, especially when we start looking at chemistry and atoms and things like that that make up substances, we get really big numbers or really, really small numbers. And so this keeps us from having lots of numbers past a decimal or in front of the decimal. So when we convert from scientific notation to decimal form, our positive exponent means that we move the decimal that many places to the right. So if it's in scientific notation, we're going to decimal form, then we move that decimal however many places to the right, whatever the exponent is on the 10. And if we have a negative exponent on the 10, that means that we're going to move the decimal that many places to the left. So positive exponent on the 10 moves the decimal to the right, negative exponent moves it to the left. Or think of it as, if it's a positive exponent, it means it was really big, so you want the number to get bigger when you move the decimal. If it's a negative exponent, it was a really small number, so we need to move the decimal in a direction that would make the number smaller instead of larger. So here we have some examples we want to write in decimal form. 3.128 times 10 to the third. So 3 is our exponent, and it's a positive. So that means we move the decimal to the right. So 1, 2, 3 places to the right. So 3,128 is our number. And see, so it was a positive exponent. Our number went from 3.128 became 3,128. It's a positive exponent means it's a bigger number. Once again, 6.4 times 10 to the fourth. It's a positive exponent, so that means we want the number to get bigger, so the decimal has to move to the right. 1, 2, 3, 4 places. And this time we don't have enough numbers to fill in those places, so we fill in with zeros in the missings. So that's going to become 64000, or 64,000. All right, 3.9 times 10 to the negative 1. So negative exponent means that the number needs to get smaller, so we move the decimal to the left. And so that becomes 0.39. It went from 3.9 to 0.39, got smaller. 6.12 times 10 to the negative fifth. Once again, negative exponent, so we need to make the number smaller. So the decimal moves to the left. 1, 2, 3, 4, 5. That's where the decimal would go. And each one of those spaces we fill in with a 0. So this becomes 0.0000612 is the actual number if it wasn't in scientific notation. All right, so when we convert from decimal form to scientific notation, just the opposite of what we did is what we've got to do. If the number is greater than 1, we move the decimal to the left until there is only one digit in front of the decimal, and the exponent on the 10 will be a positive number. If the number is smaller than 1, we move the decimal to the right until there is only one digit in front of the decimal. The exponent on the 10 will be a negative number based on how many times we moved it. All right, so here we're going to write these in scientific notation. So going from normal notation or decimal notation to scientific notation. So this one doesn't have a decimal. We would assume the decimal is at the end of the number. And so 52,314 is definitely bigger than 1. So we need to move the decimal until we get to a number between 1 and 10, which 5.2314. And we moved it 1, 2, 3, 4 places. So that's times 10 to the 4th, because we started with a really big number, made it smaller, so we got to have a positive exponent. 3.2, it's bigger than 1, less than 10, and there's only one number to the left of the decimal. So we're just going to write this as 3.2 times 10 to the 1, or 10 to the actually 0, right? Because we're not moving it any places. And 10 to the 0, same thing as 1, so 3.2 times 1 would be 3.2. All right, so then 0.0471, we're going to move this decimal. We've got to move it to the right this time because it's a small number. Trying to make it a bigger number. So 4.71 is what we have after we move the decimal. And we moved it 2 places to the right. And so going from small to big means we need to have a negative exponent. So -2. All right, so then the next one, all zeros here. To get to where we have a number to the left of the decimal, we got to move it 1, 2, 3, 4, 5 places. So that becomes 4.28. And 10 to the -5. 5 places to the right, it's a negative exponent. All right, 602 million here. Decimal is there, even though it wasn't there, it wasn't showing. 1, 2, 3, 4, 5, 6, 7, 8 places to get to one number to the left of the decimal. 6.02. And that was 3, 6, 8 places. Went from a big number to a small number, so we need a big exponent, or a positive exponent. All right, evaluate the expression, write the result in scientific notation. So here we're doing math, or multiplication or division, with scientific notation numbers. So when we multiply these, we basically multiply things that are alike. So 2.5 and 5.8 are numbers without exponents. So 2.5 times 5.8. And then that's going to be times 10, same base value with different exponents. So we use the rules for exponents we learned. So add the exponents, 4 plus 2. And if I multiply 2.5 times 5.8, that's going to give me 14.5 times 10 to the 4 plus 2, which is 6. Now, this is where it gets a little tricky, because to be in scientific notation, this front number has to be between 1 and 10, and we've got 14, which is bigger than 10. So we've got to move the decimal to the left 1 to make that a smaller number, 1.45. And since we've moved it to the left, making a big number smaller, we've got to add 1 to that exponent there. So 1.45 times 10 to the 7th is what we end up with there. Next one, 1.82 times 10 to the negative 1 divided by 1.4 times 10 to the negative 3. So it's division. So 1.82 divided by 1.4, dividing the actual numbers. And then that'll be times 10, and since we're dividing, we subtract the exponents. That's 10 to the negative 1 minus the negative 3. We divide 1.82 divided by 1.4, that gives us 1.3. And negative 1 minus negative 3, double negative there, means we're adding the 3. So negative 1 plus 3 will give us a positive 2 for our exponent there. 1.3 times 10 to the second. And the next one, this is a scientific notation that's raised to the third power. So the same rules apply. If we have a power outside of it, of parentheses, then it's applied to everything on the inside. So that's 1.5 to the third times 10 to the negative 4th. Since it already had an exponent, we multiply the exponents. 10 to the negative 4 times 3. 1.5 to the third power, or 1.5 times 1.5 times 1.5. It's going to give us 3.375. Might need a calculator when you do some of these. And then times 10 to the negative 4 times 3, which is negative 12. All right, so that concludes section 8.4.